Space, known as the final frontier, not only holds the mystery of the unknown, but it also holds an unprecedented challenge: space debris. Space debris, also known as space waste or space junk, refers to the assemblage of defunct artificial objects in space. To understand the genesis of space debris, consider the year 1957, when the first man-made object, Sputnik, was launched into space by the Soviet Union. Since then, a proliferation of space missions has seen more than 8,000 satellites launched, and nearly 5,200 remain in space today. The result is a space junkyard comprising spent rocket stages, dead satellites, fragments from disintegration, erosion, and collision events, along with tiny flecks of paint. This issue intensifies when we consider the speed at which these objects are moving. They can travel at up to 17,500 miles per hour, a speed at which even a small piece of junk has the potential to cause significant damage. Notably, in 2009, an old Russian satellite and a functioning U.S. Iridium satellite collided over Siberia, creating thousands of new pieces of debris. The problem of space debris is significant for many reasons. Firstly, the immense amount of junk makes space travel more dangerous. The International Space Station, ISS, has to regularly adjust its orbit to avoid collisions, which can cause delays and schedule disruptions. In the worst-case scenario, an impactful collision could result in human fatalities. Secondly, space debris threatens our ability to use and benefit from satellites. Increasingly, we rely on satellites for weather prediction, global positioning, telecommunications, and numerous scientific research projects. With an ever-growing amount of debris, the chances of collision exponentially increase, threatening the operation and lifespan of these satellites. A catastrophic Kessler syndrome, a theoretical scenario in which the density of objects in low Earth orbit is high enough that collisions could set off a domino effect, could render space activities and the use of satellites unfeasible for many generations, a consequence with far-reaching effects on modern life. However, space debris isn't inherently harmful. In fact, it allows space agencies across the globe to study the buildup and motion of space debris, providing valuable data. This information aids the development of technologies and strategies to mitigate potential risks. Efforts to track and catalog space debris prove instrumental in enhancing our understanding of the extent and potential impacts of this issue. Solutions to tackle space debris are both intriguing and diverse. Scientists are researching methods like using giant nets or harpoons to capture and deorbit larger pieces of debris. Others suggest the creation of an international agreement to hold nations accountable for debris created due to their space activities. Transparency in space activities, improvement in satellite designs, enforcement of post-mission disposal of spacecraft, and the development of active debris removal technologies are essential measures to cope with and control the growth of space debris. It is in humanity's best interest to maintain space as a sustainable domain free from waste, not only for our safety and security, but also for the protection of our collective scientific, economic, and exploratory interests. In conclusion, space debris poses a real risk to all spaceborne assets, human or otherwise. The long-term survival of our space activities hinges upon how effectively and swiftly this issue is tackled. The complexities associated with managing space debris illustrate the intricate nature of space activities, reminding humanity that although space might be infinite, our irresponsible actions can have long-term, detrimental consequences. Like any menace, space debris also offers an opportunity, a chance to cultivate global collaboration, technical innovation, and responsible conduct in space activities.